Hey guys, Blue Kool-Aid here. Yeah, I guess I'm kind of late to the party here a little bit, but at least I'm getting there, right? Anyway, yeah, I was watching all this last night also, you know, and all these waves coming in. We detected this first one that came through, and then I'm telling you guys, it just kept happening over and over and over again. Okay? Now, this is not coming from solar winds, guys. It's not. The solar wind is not budging. Okay? If it is, it's budging just a touch. And I'm kind of inclined to think that even at that may even be inaccurate because these satellites that give us this data may be being affected by this other magnetic field in such a way that it's fooling them to think that it might be solar wind. Now, I don't know how these actual tools actually collect the data as far as, the technicality of the tool itself. But I don't think that this is solar wind at all, because even on that tool, and I'll show you what I mean here in just a minute, but even on the ISWA tool, the models that I show you guys all the time, that is not picking up any solar and wind increase either. It did a little bit like a couple days ago, but nothing that should be causing this. Okay, what we're seeing now in our magnetosphere is something that we typically see when the solar winds get really, really high. Okay, so, I have to really keep that in mind here. So then, when we get these waves, we start wondering, where the heck did this come from? What is going on? Now, I don't know that this has ever been documented before. I don't think that it has. Now, I'm sure that we've had anomalies before to our magnetopause. I did a video a while back on how it actually reversed for a time back. I think it was 2012. It was a few hours. We lost our shields and it reversed, went the other direction, then it flipped back. Okay, now we're still wondering what's causing that. What caused that? We here in this research, we tend to think that it's other celestial bodies, and that's what I think also. Now, obviously, you're not going to get mainstream to say any of that. Okay, not to mention that they tried to hide the data. Okay, they actually went back and they scrubbed some of the stuff off that they didn't want us to see, that we actually got to see. But they forgot a couple tools. Okay, they didn't go back and erase some of the radiation belt tools where we detect, different levels of our atmosphere. They didn't get to those. They left those out there, and those are just as much proof as anything that I've ever shown you. And I've shown you and I'll leave a link to that video if you guys want to check it out. But Scott did that. I was actually making a video on this, guys, when Scott's live stream went up. So I stopped making my video. I actually posted a video, and then I went back and listened to my video, and I was like, man, I wasn't very clear on what I was trying to say there. So I just went ahead and pulled it down because I rushed through it because I wanted to get over to Scott's live stream. But basically, this is that video now. I'm just redoing it, but this will be a little bit more in depth. So please hang in here with me, okay? There's a lot to unpack here to get you guys to kind of understand what might be going on here. All right, now we're going to watch about a minute or so of Scott's video here, and I'll leave a link over to his video also. Go check it out. I mean, he's spent some time on this, okay? Not just today or yesterday. I mean, this is years of research, okay, guys? I've just been lucky enough to be able to have him appreciate what I do enough and think that I'm even able to understand what's going on enough to share this stuff with me and, bring me along to the point to where I'm at now, to where I feel comfortable enough explaining things, So I just want to put that out there. But we're going to listen to Scott here for about a minute or so, and he puts it, this is really the summarization, kind of, sort of, what started all this, okay? So here we go.
Earth in blue, Luna signifies the moon. And then we have little teeny tiny Mercury over there. So as you can see where the positioning of Planet X would be and the positioning of Earth, what caused these waves to come in and flatten out the magnetopause? Solar wind? No, don't think so. There was none. There were no impacts of solar wind coming from the sun. The next predicted minor impact won't be till July 3rd or 4th. So that's what led me to go and start looking at all of these dynamics and then trying to figure out, okay, these impacts to our magnetic field were substantial. I mean, they were big, and you're going to see it. So something very, very powerful would have the ability to disrupt our magnetic field like that. If it wasn't solar wind, it wasn't a coronal mass ejection, there were no solar flares, the sun was pretty calm, except for some plasma releases on the eastern limb of the sun, which wouldn't even affect the Earth. Where did this energy come from? And then I started looking at the positioning of Earth, this Planet X object in its orbit around the sun, and bingo, it all started to come to light. So,
all right, guys. Yeah. So I mean, he said it pretty much. What's going on here is, let me get my draw tool out here. Okay. Obviously, he just explained to you guys what he thinks is going on here, and I agree. Okay. We've been talking about a 28-day orbit of a Planet X object around the sun. Okay. Now, the question's been asked to me, and I'm sure Scott's had a lot of these questions also. And we've explained this before, but I'm going to go ahead and explain it just a little bit more. Okay. This is Planet X object. Okay. This is 2019, right? 2019. Well, I'm not sure. This is just a rough estimate, okay, guys? This is just to show you basically what has happened here. Well, 2018, this object was probably here. 2017, you see where I'm going with this, guys, and so on and so forth. What's happened is it has got, its orbit has gotten smaller around the sun. It's gotten closer to the sun in its orbit. Okay, now why does that matter? Well, because the Planet X object itself, okay, we think it has a very, very powerful magnetic field. Okay, it's powerful enough that it's probably even influencing the sun's magnetic field at this point, which is kind of what we're seeing here. Okay, so with that being said, the alignment of this really matters. Okay, and this happened back when our magnetopause flipped back in 2012. Okay, it had everything to do with alignment of other planets, of us, where everything was lined up in the solar system. Okay, so that's true for anything that goes on in space. Alignment matters because there are so many different forces out there that affect this. Okay, now I'm going to say this again. This was not solar wind. Okay, it just wasn't. At first glance, people would think that it was. Okay, and to be honest with you, I thought it was at the beginning also, until started digging a little bit more into it. Okay, because if we get a solar wind and we have that bounce on our magnetopause, you know, we see that from time to time, guys. That's what's going to happen. But when it's not coming from the sun, this did not come from the sun. All right, that's why this is important. Okay, are we going to see any effects here on Earth? Well, I think that we kind of might already be. All right, if you guys take in consideration the huge heat wave, they're calling it like a blowtorch over in Europe right now. 114 degrees in France. Okay, has anybody ever heard of that over there? Okay, and I did and I did a video a while back on UV rays, UVA, B, and C, and that's very important. We're now getting UVC on the surface. Well, why is that? Well, this is part of it. When our shields break down, it allows stuff in it, into our atmosphere. Okay? Ozone is what really is supposed to block UVC. UVC is the most dangerous UV that you can get, okay? I'm not sure if there's anything bigger than that. I'm sure there is, but I'm not sure if it's classified ultraviolet or not. But that UVC affects us at a molecular level, DNA, okay? So, you know, when that stuff is, even if you go back and look at the articles, you will find that what they're going to tell you is that they don't even really test for that, because it's only supposed to be able to come from artificial sources here on the surface. Okay, they've just thought that our atmosphere was blocking and absorbing all of it, and it was up until a few years ago. And I have to give Mr. MBB3 some credit there, because his network of things that he's got going on, they're detecting UVC on the surface. Okay, and it's not supposed to be happening. So that opens up a whole nother can of worms. But what's going on with these waves? Okay, no increase in solar wind, like Scott said. No CMEs, coronal mass ejections. No big coronal holes, because number one, if it was a coronal hole, we would have seen an increase in solar wind. That's what causes that. Okay, there were and Scott mentioned here like a plasma filament release from the sun. Even that itself, when that releases, depending on how fast or how hard it comes off, it still takes a couple, 3 days for that stuff to get here. So even if we looked at it today, the stuff that's coming off the sun, unless it's a flare, takes some time to get here. Okay? So this is not coming from the sun. I just want to stress that. I do think that it has everything to do with this 28-day orbit. Okay? And I'm going to go a little bit more into it, but you see how we're aligned? I mean, we're aligned straight like this again. Okay, and this happened back in 2012 when this was in a different position, and it was probably out here somewhere. Okay? But we were lined up with all three of them, and Mars was actually close there too. And if you go back and watch my video, you will see that. Okay? Mars reacted, and then we reacted 4 days later. Okay? Because the Planet X object was orbiting. It moved, and so did we. So, and that's what's going on here. That's why we're seeing these anomalies happen with no explanation. This was not what I've heard this said already too. I had an email about it. Stealth CMEs, okay? Those are CMEs that are really, really hard to detect, okay? Typically a CME, when it hits us, it doesn't last for days, okay? It's usually a multiple hour event, and then it goes away, right? Okay, that's a typical CME. This is not going away, and it actually came in. We started reacting kind of slow, and then it ramped up, and then it went. And I'm not sure if it's starting to ramp down now at this point. The last time I looked, it wasn't. So, anyway, where are these waves coming from, right? And like I said, I think Scott's dead on right here with this. Because, you know, we got to keep in mind, this right here, guys, Jupiter, okay? I mean, that's a huge thing. It plays a factor in everything, okay? When we're aligned in certain ways, all right? And I don't know the science behind all that as far as the alignment and the exact, I couldn't tell you technically why that happens and how that affects us exactly. I could give you a roundabout, you know, educated guess, I guess, if you want to put it that way. But I think the more important thing here, guys, is our alignment with us, Planet X, and the Sun. The alignment there. Okay? So, why only every 28 days? Okay? I've had this question asked too, because you got Planet X here. Well, I'll tell you what. I'm going to back off of this. And we are going to go to my gallery real quick. We're going to go here. Now, this is part of Scott's video. I had this picture somewhere else. It was just easier for me to screenshot it. Okay? This is something that he's come up with, okay? He made this diagram and all that, okay? So, people ask me, well, if Planet X is orbiting the sun, wouldn't it stay the same distance around the sun and react with the sun all the time in this way? No, and I'm going to tell you why. Okay? Okay. Planet X is in a highly elliptical orbit. What does elliptical mean? Well, if you guys look at Mercury right here, that's basically on the ecliptic. It's kind of slanted, but it's not much. Okay? You can tell the difference, the distance between the end of the orbit here to here is roughly the same as it is from here to here. So that means it's not elliptical. Okay, it's going in basically a circular motion around the sun, staying roughly the same distance. Not exactly the same, but it does stay roughly the same. Planet X does not do that. Planet X object does not do that. Okay, this is a great diagram to even illustrate that. Okay, you see how close it is here? Now if you take that and you put it over here in its orbit, you see the distance to here to there is only that far? And then when it gets out here, when it's basically halfway around its orbit, which would be every 14 days, well, every 28 days, but in the half of it would be 14. See the distance there? That's why we don't see the reactions all the time. Because this thing gets out further away from the sun. Now, something else. Earth's connection to the sun, it disconnects and reconnects every 8 minutes. Did everybody know that? I didn't know that until Scott told me that a few weeks back. I didn't know that. So that could help explain some of these waves. Now, something else, are we, and this is just something I'm throwing out there, I ain't saying this is actually what's happening, but if Planet X has a very powerful magnetic field, which we believe that it does, Planet X object, I don't like calling it whatever this and that. I think it's a Planet X object because I personally, I don't know. I think that it probably is Planet X, but at this point, it's a whole system is what I'm calling it, all right? But this one particular object, it's powerful enough, its magnetic field is, I think, that we may be, when we flip connections, we may be jumping, because when it gets close to the sun, maybe it's like a short in your electrical wires, if anybody knows anything about electricity. Maybe it's the magnetics are kind of shorting out, and we're just hopping back and forth. No rhyme or reason to it. And it's causing some of that. Okay? Now, the solar cycle itself, guys, okay, what that is that's the reversal of the sun's magnetic poles. Okay? That's a basic thing. Okay? It's a basic statement there. I mean, it's a lot deeper than that, obviously. But it's roughly every 11 years it does that, and that's kind of what they say is as a solar cycle when those poles flip on the sun. So you take that in consideration, not to mention that we don't know exactly what kind of magnetic field this object has. So what if it is in a process of flipping magnetically along with us? Remember, our poles are in a rapid movement towards each other as far as magnetically. We're rapidly going into a magnetic pole reversal, okay? And everybody's been doing videos on that, and I've done multiple on that. So you tie all three of these things together, okay? The uncertainty of what Planet X is actually capable of. The uncertainty of how strong its magnetic field and its influence on the sun and the sun on it. And then in turn, all of that is influencing us. Okay? Because we're all connected magnetically in this solar system. You guys have to understand that. Because that is what's going on. Alright? So when we see these waves of energy come through and they hit our shields, okay? I mean, and we don't have any explanation for it really. We don't. I would venture to say that you're not going to see hardly any mainstream even touch this subject. So, if I'm wrong on any of this, and chances are I probably am. If I've not explained this well enough, at least to that extent. Now I'm going to take you guys over and show you what the magnetopause is actually doing, because if you haven't seen this yet, it's probably going to blow your mind a little bit. Okay, because it's a very, very intense reaction. It's not slowing down, it's continuing, and the winds are not. Matter of fact, I'm going to take you guys. Let's just go over here to space weather. Okay. Now, what this is this is the space weather site. You can get to it from Scott's webpage, planetxnews.org. There's a link about halfway down, or you can just simply Google it, go here, what have you. Okay. You see right? Space weather overview. Okay. Here this is supposed to be showing flares. There are no flares. Okay. Proton flux, way normal. Okay. It's in the 0. You see this over here? We're not having any proton flux, right? Okay. Geomagnetic activity. This is the KP index, guys. Why is this thing not showing anything? Okay. Because this is different type of energy that it's looking for, I think. Okay. Now, we did see an uptick. Typically when we get high solar winds, or we get a solar flare or a CME, we'll go into a geomagnetic storm. Okay, and it takes a few days for it to get here. But our magnetopause is reacting in such a way that it looks like we're getting smacked with solar winds or a huge CME or a solar flare, whatever. Our magnetics are reacting. But yet we're not seeing any significant increase in the KP. Okay? So why? You know? And like I said, it's not solar winds. And like I said, typically when we get solar winds, our KP will go up. Something else I'm going to show you guys real quick while I have you here. Okay, this model here. This is the model that shows, if you look over here, at the top, that's the density. That's the plasma density. Okay, where Earth is at. That's the green line is Earth. Here's the radial velocity. This is the solar wind speed. At no point on this graph does that get above 400. Okay? When we have reactions like we're seeing right now, typically this, and I'm not even going to play that. It's not even worth it. Typically, we will see the solar winds go up. Okay? When we have these reactions. Well, you can tell right here, even according to their model, that it's supposed to be like progressively going down. That's what they're predicting. This, if you see the dates, this is the 29th. Right here. Okay, so this is actually a predictive and a historical chart. It shows you like 1 or 2 days, and then it tries to predict all the way out, okay, to the 5th. All right, now you see our solar winds are supposed to really taper off. And it never ever got way up here. Okay, then you start talking about density. Density is basically the density of the ions. They're calling it plasma density here, which is what it is. But we all know what density is, so, basically, I guess if you want to use a general term, I'm not sure if you want to use mass, or I don't think it has anything to do with weight, but I could be wrong. Anyway, when the density goes up, the solar wind's supposed to go down, okay, and vice versa. Now, we see them react very similarly, going the same direction every once in a while. When we get like we have a solar wind that's made it about halfway here. And then the sun will have a CME that's moving faster than the solar wind. But then what happens is the solar wind kind of grabs that energy that density, all those dense ions, and it brings it with it. So sometimes we'll see that, and that's what will cause these charts to kind of act in the same direction. But typically, when the plasma density goes up, the wind speed goes down. And then vice versa. If the wind speed goes up, the plasma goes down. That's just the way that it works, okay? In normal conditions. And again, here's the ace. Now this, don't worry about this break, because that's a normal thing. I think it's when the satellites go behind the Earth, I believe. Between, well, the Earth's in between it and the sun. Anyway, you can see here too, the density is the orange, and the wind speed is the yellow. Again, look at the wind speed. Never ever breaks 350. Okay, we've seen smaller reactions with the wind speed hitting 600-700. Okay, so I wanted to show you that real quick. Now, I'm just going to take you guys over here, and I'm just going to show you a few of these, because these right here will be the models of the magnetosphere. Okay, just bear with me here while I get this going. I know I'm kind of doing whatever here, but I really want to show you guys what I got here. So, and I want to show you guys that it's continuing. Okay, that's something that I really want to hammer home here. And there's a couple things I want to explain. It does, the last few captures that I've seen, it does look like it might be starting to subside a little bit. But even these little still shots, guys, you can see that this isn't normal. This is not normal conditions. It should not be doing that, is what I'm saying. I mean, it's not like horrible looking at it, that one. But, yeah, these are not normal conditions. And, you know, when something's not normal and we can't explain it, or explain it away with typical accepted solar wind teachings and what's going on in our solar system, if you can't explain it there, then you got to look outside of that, guys. You can't just, you know, go on thinking that, you know, things are going to be staying the same, because I think anybody watching my channel or any other research channel like Scott's and Jeff's and everybody else is, you know, you got to have some sort of an open mind to be able to go outside the box here, okay? And really, any good scientist, and I'm not calling myself a scientist by no means, okay? But any good science discovery has always been something way out of the box that people didn't think, no way that's true, okay? So, and they were just brave enough to explore it and then even come out after that. Okay, now I'm going to explain a couple things here. Okay, I am going to pause it because, as you guys can see, guys, this is not slowing down. Look at this. All right, this is today. This is just a couple hours ago right here. Right, this is still happening. All right, and I'm going to take, oh wow, I just see that. I'm going to show you guys something here in a minute. Are you seeing, see all this bouncing around? Okay. What's happening there is we're getting hit with energy. Alright. And then we get what's called rapid expansion. So it compresses us and then we push back. And when we push back, we're pushing back so hard we expand out further than what's normal. Okay. That's called rapid expansion. But you can see, yeah, I mean, look at this. And I'm going to show you another way to it's not as accurate because it can be fooled, but I'm going to show you another way to at least get some sort of a rough idea if our solar winds are moving or getting faster, okay, here in just a second. But we're going to run through this real quick. All right, now this is about the turn of the day, okay, that's the 29th last night. All right, that's right at the end of the day. This is UTC, guys. I'm on the East Coast. There's like a 4 or 5 hour difference there. So wherever you're at, just I've left links before to a site that will compute that for you if you don't know where you're at, to UTC, which is Universal Time. Okay, So I'm just going to toggle through here, and what you guys are going to see, and anybody that's been watching any of this lately is going to see this. Now, something I'm going to point out. This is kind of minor at this on this particular capture, but do you see this line right here? Okay, notice how it's crimped down over here, and it's not over here. Okay, so we're getting compressed right there. Okay, and it's even more intense on a couple other captures, and I'll show you. Okay. Now you see that jump? Boom. Okay. See that expansion? Okay. Look how we got compressed. You see that line? See how it come real close? Okay, this dotted line is where the satellites are, guys. Alright. I'm pretty sure that this is the surface, the black disk. And while that is in the middle, showing you the light and dark side of the sun, or of the earth, the sun's over here. Okay? Just keep that in mind. So, that's at 119. And then at 123, 4 minutes later, that's what it looked like. Okay? We got compressed. Right? Well, I'll just take you back 2 frames. See how we're getting compressed right there? See how it's almost flat? That's another thing that is kind of odd. This is a bow shock should be bowed like this. Okay? This is almost flat, if you can see that. Okay, I've seen it more flat before, but we'll go back one more just to see. Okay. Now, we do see this double signature out here a lot. Sometimes we see triple, and you're actually seeing some over here. Now, it is important to note that when this energy gets inside that satellite orbit, that it's really close to us. Okay? I've seen it actually get down into the surface. Alright? You know, so that is what it is. But there's something else here, so we'll just keep on going here. And I'm sorry if I'm all over the place, but this is something I really want to get out to you guys. I feel like I need to chime in here because I do watch this model especially a lot. And I watch it a lot more than a lot of people do. Now, you seeing that? Now, look, guys. Okay, here's our compression. That's when it hit us. We start doing the rapid expansion because we're pushing back. And Earth's doing what it's supposed to. It's fighting this off. Don't make no mistakes that the Earth ain't fighting here. That's why this is doing this. Okay? You wouldn't see any of this if the Earth had given up. Just letting you know. Okay? Then that. Okay, now look at this. Now, this is something I have to point out. I've been watching these for a very long time, guys. Okay, and I've seen these things compress, and I've seen them do weird stuff. Really weird stuff. But if you look here, you can see it faintly, and I wish this was bigger. I really wish they could make this bigger. But you can see how this is curving up like this at the same time as this. Okay? And then you got your typical shock out here. You guys see that? This is extreme. What do I mean by that? Usually you see this right here. It's kind of doing one of these numbers, and you'll see it basically almost at the same time down here doing the same. That's typically the shape. But whatever we're getting hit with, this magnetic energy is really, really intense. Okay? I'm just going to say that because that's what it is. Alright, now you're seeing it go the other way. We're going to calm down. That was basically a wave, right? And keep in mind, this is like 2 or 3 waves after the initial one that hit us yesterday. Okay, you're seeing this. Okay, we got hit there. See that? That's intense, guys. See, we expanded out. Now look. This right here is showing you the wave action. Okay, what am I saying about that? Solar winds, when they hit us, they don't typically come in really short bursts, okay? They do come in bursts, and they don't stay completely consistent until they die off, but they tend to go up to a certain level, stay there, and kind of taper off. But when you see these waves, Oops. Wave, 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 wave. Okay? When you see that, that is, yeah. I mean, it's getting, something's getting really, really jacked up. Okay? Now, we're, like I said, we're fighting back. We're holding our own right here, but, I mean, it is definitely inside the satellite orbit. Okay? And it does get closer, too, in certain aspects here. And again, and I'll show you what I mean here in a minute, but see how we did that rapid expansion? Boom. Getting ready to get hit again. Look at that. That hit us right on the chin, whatever that was. Okay, we expanded back out. Again, here we go. Boom. Again. Now, I'm going to address something right here real quick, too. Okay? I have to point this out. When you see these jumps, and I've said this before in previous videos, okay, when we jump from that to that in the next capture, you really have to look at your timestamp. Okay? Timestamp is down here, or you can look up here on this model. But I'm going to go back one. Okay, look at the timestamp. 7:54. The next one, 8:44. Okay, there's 50 minutes of missing data. Okay? Now, I used to think that every time that happened, that they were shutting these things off trying to hide something. Right? Well, I don't think that that's probably what's going on here, guys. Okay? These satellites have safe modes. Alright, so when they get hit with high energy, if they start to detect really intense stuff, they go into safe mode. They shut themselves off, basically. And at least their main components, because here on the Earth we're protected from all this solar stuff, all this cosmic rays, all that. These satellites aren't. Okay, so when they have to be protecting themselves. If not, they would just get melted, and basically the insides of them would just, yeah, get fried. Melted's the wrong word, but anyway, yeah, you see that jump. Whenever you see those kinds of jumps, always look at your timestamp. If you see a jump like that and the timestamp doesn't move, call me. Because that would be crazy. Anyway, yeah. But something else, and like I said, we're talking about waves of energy. Okay? Hitting us. Magnetic energy. Coming from wherever. Probably the Planet X object and our connection to it and the sun. So what I want you guys to watch here is look at the front. Watch the front right there. You see that little boom? And it's going to come right on through. You're going to see it go right over. Watch. Here we go. Boom. Do you see that? You can see it because it gets light blue here. And then you'll see the light blue move back in the next capture. And then it kind of shoots on off to the back. Try that again. I'm going to try to do it as slow as I can, guys. Okay, it's coming through now. You see it moving? And then boom. See it going back? Now toggle it back. Boom. See that? And it does it multiple times. See that? We got hit again. I mean, like right after it. So this stuff is not slowing down. Okay, now the intensity of it, it's hard to say how intense this is. Okay, now this is something else that is kind of strange. Alright. This is why I think it's magnetic. Alright, because if it was solar winds, it would be consistent in color. Okay, what do I mean by that? You see the break here? Where the red comes up here and stops? That's indicative of some sort of electrical connection kind of jumping around. Magnetic connection. Electricity, magnetics, kind of the same. Not exactly, but yeah. It's all related. But if it was solar winds, you're not going to get solar winds hitting you up here, and then taking a break, and then hitting you down here at the same time. Okay, if it's going to hit our shields, it's going to hit us. And it's going to spread out when it hits. Okay? So what I'm saying is that we may have something just jumping around electrically or magnetically here, and that's why we're seeing these different directional, at least out here in the front. Now, we can kind of tell direction of where the object is coming from just by watching it go out the back. And here, as of late, and this falls right into where Planet X would be sitting, it's pointing this direction, okay? When you're looking at this model, you're looking at it from the side. Okay, so it's pointing down. Basically south of the sun, all right? So that is very indicative of where we think Planet X is right now in its orbit. Or Planet X object, whatever you want to say. I'm tired of vocabulary there, guys. I really am. It's like you got to walk on eggshells when you use words like that. People just rip you for it. You know, man, I'm just going to call it a Planet X object from now on, system, whatever we want to call it. That's just what I'm going to do. You know, because none of us are standing on it. Anyway, but yeah, I mean, I do tend to think that the object that Scott's tracking, your 28-day orbit, is probably most likely Planet X. That's my opinion. Okay, but it does have other objects with it. All right, now, those other objects, I'm going to talk about that for a minute too. They will have magnetic signatures also, guys. Okay? So what if all these objects are interacting with each other? We got the solar cycle, the poles of the sun reversing. We got this massive magnetic influence of the Planet X object, plus whatever bodies it's got with it. Our poles are getting ready to shift or reverse. Okay? All this stuff, and you know, like I said, I would love nothing more than to be able to call this a solar wind event. Okay? I really would. Because then it's explainable. Most definitely explainable and easy. Okay? This is not easy. There's a lot of stuff to unpack here, guys. And just to be honest with you, we're going to be unpacking this for a very long time. Alright, now you can even see direction here too, guys. You see how it's red down here and it's not up here? So, when you see those reds, you can kind of think of it in the heat sense. It's when the two pressures hit each other, and when they're hitting each other harder, there's more heat, right? That's just a basic thing there, but yeah. And you see it tilting up and down and going all kinds of crazy directions. Now, I'm going to take you over here to this one because this is the one that I really want to show you. I'm going to pause it. Now, typically, okay, we should be able to trust this number up here. 409. That's supposed to be directly related to the solar wind. That's 409 kilometers a second. That's these arrows that you're seeing on this, that's the direction of the solar wind. Okay, that's what this model is showing you. Okay, just so you guys know. But in instances like this tool is probably malfunctioning in some sort of way or giving us a false reading, because this tool here is even not showing any kind of massive increase in solar wind. But, you know, it could be gravity waves. That's something I haven't talked about yet, too. None of these tools pick up on gravity waves. Okay, that could be part of this also. Could be a big part of it. Alright, so, you know, and I'm doing, I don't know an extreme amount about gravity waves, but I am researching that. I'm starting to learn a little bit more, but I'm not really comfortable just going out there and saying, hey, this is what it is. So, yeah. But we can look there. We used to be able just to look there and have a really good idea what the solar wind was. But we can't do that anymore. We can just to get kind of a rough estimate. But if we want to get the real number, we have to go over to space weather or some other site and get the actual solar wind speed from there. Because this could be being influenced by these waves, causing it to not give us the correct reading. In other words, this may think that it's seeing solar winds, and it's not. It's something else. Because none of this stuff that we're seeing right now, anybody predicted. Nobody. Okay, as far as solar wind, nobody predicted solar wind. That's what I'm trying to say. Scott's been talking about this is going to happen for the past few days anyway. Okay? You know, and I was in agreement with him that, hey, yeah, this is what we're seeing, and we really need to watch. He even sent me some text messages and Obviously, I'm not going to show them or whatever, but he's like, man, we really need to watch this in the next 3 or 4 days because it's really going to get. I really think that when this Planet X object comes around to where it's at, we might see some effects. And lo and behold, look what happens. Okay, so yeah, but I wanted to show that to you real quick. Okay, so what we're going to do is we're going to watch this. Now keep in mind those arrows is the direction of the wind. Okay, and I'm going to show you something kind of funky. All right, now sun's over here and it's shooting winds at us. Okay, you see this arrow here in the front? That's pushing directly against that. How is that possible? I mean, it's possible. I ain't saying it ain't. But that means we're pushing back hard enough right there that we're meeting the sun right there. And then typically we don't see that on these models. Not out that far. The solar wind should be strong enough to keep everything moving the other direction, is what I'm saying. So that also lends itself to maybe this isn't solar winds. Maybe this is, a magnetic disruption coming from somewhere else. Something else we really haven't spoke about here, and I don't know if anybody else has talked about this either. Now, I don't know if this object, the Planet X object, could actually produce its own winds. I don't know exactly what it's made of. I don't know if anybody really does. I know there's a lot of theories out there. I don't know personally, or even have a theory on that, but it possibly could be producing its own winds also somehow. I don't know if it has, those properties like the sun does. If it shares any of that or what have you, I don't know. But that's something else to consider, that we may be getting maybe it's producing some winds too. But look at this. Guys, it don't get any more intense than that red color. Okay, now something else I want to show you here. You see this up here? That says 417. Now, remember I just told you this is kind of a general way to look for the solar wind? In the past, when we would see this big red, you would see that thing jump up to 1,000. Okay? So I don't think that this is solar winds. Not even one bit. Okay? I mean, I don't. I truly don't. Now, something else we're going to talk about here. Okay, now it never got it, according to this model, when we got hit with that. Okay, now look at this. Right, see how we got compressed? This is that big compression event just happened a few hours ago. Okay, and boom. It goes right around us. It hits us, boom. Now look what happens here. Now I'm going to show you guys this, and I'm really not trying to be fearful or anything here, guys. But see this yellow color? This is our bow shock out here, right? Well, look how it blended right in. Okay? I mean, does that not look like some energy's getting through there? I don't know. I just don't. But to me, we're getting compressed. We're going to do rapid expansion right here. You're going to see it. This is very, very, this is a good model to show that. Okay, we get hit, compressed, and then rapid expansion. Okay, then it goes on off. Now we're going to get hit again. Boom, again. Like I said, guys, this is multiple waves of stuff. Look at this. And the whole time, even if you were to say this is solar wind up here, that thing in these past few waves, those big waves I just showed you, watch that thing. It doesn't even get up over 400. Okay, now right there it did a little bit, but and like I said, even that number is not that high. We shouldn't be reacting like this. If that's an indicative of what the solar wind actually is, which I don't think it is. So, but yeah. So you guys can see all that. I mean, this is just crazy, crazy stuff. Okay, and I have a lot more to show you guys, but this video is going pretty long already. So I guess what I'm going to do is I'm just going to show you guys this right here. This is our lines of connectivity. Okay, closed field lines, polar lines. IMF lines is our connection to the sun or other celestial objects. So I have to throw that out there. That's the blue lines. You're going to see these waves. Okay. Now look at that. See how intense that got? But yet we didn't see any huge increase in solar wind. I mean, and I know I keep saying that, and I know it sounds like a broken record, but I want everybody to understand that. This is not solar wind event, guys. Alright? Solar means it came from the sun. Is it possible cosmic winds or what have you from another object? You know, I just talked about that a minute ago. I don't know if it's possible or not. You know, I don't have an answer for that. I'm just throwing that out there. But see, you see all that? I mean, and it just keeps coming, and it's not over yet, guys. I'd like to say that it is. Something else I'm going to show you guys here, too. We're looking at this. When you're looking at this model, you're seeing it. You're looking at it from the side. You're looking at planet Earth from the side right here. Okay? So when you see the direction of this, that means it's tilted down. Not to the right. It means it's tilted down. Okay? So if the sun's over here, and our Planet X object is down here, well, that wasn't very good. Let's do this. If the sun is right here in front of us, right? And the Planet X object is in its orbit, and it's down here right now. Doesn't that line up? Just saying. And if our, you know, our connections are dropping and reconnecting every 8 minutes here on Earth, you know, to the sun, maybe when we go do our connection to the sun, maybe it's shorting out a little bit. Maybe we're grabbing hold of this Planet X object for a minute. Or maybe we're connected to all of them at the same time. And so when these two, when the sun and Planet X react with each other because they're so close, maybe that's what's causing this. We're just getting these waves coming, you know, magnetically. Not, you know, not solar winds being carried that way. Not the energy getting carried that way. We're talking magnetically. All right. So, you know, I'm not going to go into electrical discussion here because that would take so much time to kind of explain how that would work. But magnetics and electricity are very, very codependent on each other. Matter of fact, they're kind of one and the same, but they're not. But anyway, I'm not going to go into that right now. But I do want to show you a couple more things before I get you guys off of here. Okay? And I'm sorry this is so long, but I do think this needed a good conversation. Let me go to... Alright, we'll just go to my gallery here. Now this is another model that we can go to, and the link's over there at planetxnews.org. Okay, it'll say Magnetosphere model. Okay, you guys see this? This was at 8:17 today, UTC. Again, just a few hours ago. There's basically no shields there. Okay, now keep that image in mind. I think I have another one I could show you on my screenshots here of what that's supposed to look like. Let me see. I probably don't, but we'll look. You know what, screw it. I'll just take you over here. Again, this is Scott's website, planetxnews.org. Guys, there's good articles on here. And if you guys just go back and you listen to some of his stuff, especially the past couple months, you're going to see that he starts talking about stuff, and almost 2 or 3 days later, the stuff that he was talking about might happen, does. I'm not sure what his actual success rate there is, but I would have to say it's pretty high. And he's talking about stuff that isn't being talked about a whole lot. So, you know, you got to keep that in mind. And he's come up with this kind of stuff, and he's really been able to get a very intuitive way of thinking here, and some of the stuff that he says that's going to happen in the next couple days, most of the time, guys, it does. He doesn't get on there, guys, and just start throwing vocabulary out there. Okay? He's not sensationalizing, and there's a lot of channels out there that do. He's not fear-mongering, just like I'm not. Okay? There's no fear here. I don't fear stuff I can't control, and I can't control any of this. Okay? None of us can. It doesn't mean that we have to be stupid and not look at it and pay attention to it. That's why we do what we do, so people are aware. So at least when stuff does happen, we can be prepared enough in our minds to not go nuts. Okay? So anyway, here's these links. All these links, guys. I mean, there's so many of them. We'll go over here to the magnetosphere. Like I said, that's it right here. Now, we're probably going to see something kind of weird too anyway. This is another way to look at solar wind. Now, on these models, guys, the sun's actually on the other side. Okay? They just flipped it around for whatever reason. I don't know. But the sun's over here. Okay, here's a velocity one. Here's a density one. Now, this one here, guys. Now, the white is low, low, low density. Okay? Basically nothing there. So, when you see the blue, that's the higher density stuff. We'll go ahead and watch this one for a second. I think this is a cool one, because it gives us a different view. At least a different, I don't know, something different to look at. But anyway, here's the pressure one I just showed you guys in that still shot. Now, it kind of looks like we may not be able to get a normal capture. What's bad about this particular one, guys, is it does not let us go back and look in the history. There are no archives of this, at least that I can find. So, you know, that is what it is, I guess. But, you know, so whenever I get on here and I'm looking at this and I see something that might be, might need to be looked at further, I will just do a screen recording of it. So if you guys are doing the same, that's what I would suggest you do. Just keep your screen recorder ready to hit record when you go over here. So if you see something, you can just record it real quick. Always make sure my audio's shut off on my recording when I'm doing that kind of thing. That way I'm not talking over myself. Man, anyway, I don't think we're going to get this thing is moving extremely slow. So, yeah. Well, maybe not. Here, let's do this. I'll tell you what. I'm just going to back out of this. We'll go back in there, see if that might make it a little faster. And then we will just look at one of them. So it ain't trying to load two. Okay. Man. Thing is moving slow. Anyway, you guys can kind of see what this is supposed to look like. Oh, there it goes. Alright, come on. Come with me, come with me. But yeah. Here it goes. Okay. Well, we'll watch it here for a minute if it's going to let us. But yeah, guys, I mean, like I said, I made a video yesterday and I didn't feel like I explained myself well enough, so that's why I pulled it down. Pulled it down pretty quick after I listened to it. So, those of you guys, I think it was like 150 that already viewed it. Hopefully you guys can get more out of this one than what I gave you. I was rushing through it just because I wanted everybody to get over there. Now, see, look, guys, this is current. Our shields are not, man, I have just, wow. I didn't really kind of expect that. Sorry, guys. Yeah, this is not normal in one bit. Okay? Just letting you guys know that. Not even close. High solar winds don't even do this, guys. This is something that, there is, yeah, the pressure just isn't there. See, it calls it pressure right up here. This is the pressure model. Okay? Basically, if you think about that, you're not going to have you're seeing what it's showing you basically is the heat. Again, like I said. So when you see the reds, okay, that's the Earth magnetic field pushing up against whatever's coming at us, like solar winds or whatever. And where those two meet is where the color comes from, the heat. Okay, so when you're not seeing anything like this, it's not normal. That means that there's nothing going on as far as high solar winds or even normal solar winds, our shields are not pushing back. Okay? If we're not pushing back, that means there's no resistance. Okay? So when there's resistance or friction, there's heat. So if we're not pushing back and we're getting hit from the front like this, or down here, however, it's coming through. Alright? Now it looks like we're working a little bit, but this is not, yeah, this frankly, it just ain't good. You can even see how this is tilting this way, okay? Which, again, points right to that 28-day orbit where Planet X is sitting right now. I mean, yeah. And I went back, and I went back like 28 days. It was like a 3 or 4 day window. Because, guys, even when it's in an orbit and it's predictive, it doesn't mean that it's going to have the same reaction when it gets close to the sun every time. It may be within a day, 2 or 3, and it starts having some bigger reactions. That's why you have a window there you can look at. But I was seeing stuff as far back as 4 months ago on a 28-day cycle. If you go back and look, you'll see that there are no solar winds on those days, but yet our magnetopause is reacting. So it wasn't as intense as what we're seeing now. I don't know why it's so intense now, but that's what's going on. Just have to say that. And this is something else I'm going to show you real quick too. You see this? This is the CME tracker. Look at the dates up there. Okay. Last date was the 28th, and they updated this like a week ago, and they haven't updated it since. And I don't know why. It's kind of odd. They don't typically do that. They typically update it quicker than that. But there's a lot of stuff here, guys, that you can go look at. And again, when we're seeing these disruptions, we got to pay attention to earthquakes. Okay. So if you guys go to USGS, you guys are going to see all these. I'm sure a lot of you guys probably already do. Go watch Dutch Sense. Scott talks about it a lot. Bennett's Suspicious Observer, BP Earthwatch, all that. All those guys are great people to go see for these kinds of things. See here, UV. If you guys want good information on UV, A, B, and C, because C is now hitting the Earth, go watch Mr. MBB3. And my report on it some. I did a video on it kind of explaining what UVC is. Now, yeah. So, there you go. Is there anything else I wanted to bring to you guys before I get you off of here? Let's look at this real quick. Let's see here. I really wanted to show you guys what a normal... Yeah, I'm not going to be able to do it, I don't think. I don't think it's there. Oh, goodness. Let's see here. But yeah, guys. I mean, I started seeing this about a week ago because it started coming into its orbit and it was catching. Now, I did this, guys, like a week ago. I just haven't put it in a video yet. Do you see this right here? This is something I was putting together. What direction is that? Same direction, right? Again, here. Alright? You can see how it's pulling our magnetopause down this direction. Okay? I don't think I've ever seen solar wind do that. It has to be magnetic because it's pulling it. Okay? It's pushing and pulling at the same time, causing that arc from that direction. That's what I'm saying. But, you know, I could be wrong. Again, wrong a lot. So, I do come out and tell you guys when I am wrong, though. But anyway, you guys see this right here, right? Typically, you're going to see it out here like this. You're going to see this thing kind of look like this, and it's going to like that. That's basically what you see, and none of that's there. Okay? That's the whole point of that. So, but yeah. Anything else? Let me go to my... I kind of did this. This was the initial one from yesterday, guys. Okay, obviously you can see that that was way more intense. And again, look here. Even this model is saying, hey, there is no solar winds, not enough to cause any of that. And this is something that kind of bothered me too. You see this out here, this blue? I don't think I've hardly ever seen that out there in front of us. It shouldn't really be like that. The energy should be stronger. Now again, why are we reacting in such a bad way? Well, you guys, like I said, guys, our magnetic field is weakening. Okay? They said it was at 10 or 20%, and they predict it to be like 95% weaker very, very shortly. At least some reports are, some articles. So keep that in mind. Any little thing is going to cause us to react when we're this weak, getting weaker, because the sun's in a minimum. So I've heard talk of, maybe the sunspots and stuff are going to start coming back, on the other end of this cycle. I don't know exactly what the cycle dates are, but yeah. So given all that stuff, guys, I mean, there's enough here for me to confidently say that this stuff did not come from the sun. Okay? And if it did, I want somebody to please tell me and show me how to get to that information. Because this is something that is, frankly, it's kind of disturbing. Because if we're seeing this kind of stuff and it's not coming from the sun, it has to be coming from somewhere. And in my opinion, they probably know what that somewhere is. Or where that somewhere is. So, and, if they think it's important enough to hide, then it's probably pretty raunchy. So, but anyway, guys, God bless. Yeshua saves, and you can drink this Kool-Aid.